Right, so this is question 8 of the June examination paper. It's a graph interpretation question, and it says the following graphs show the course of two St Mary's buses that travelled to Durban Girls College for Derby Day. And you can see that there are two different lines. This is bus 1 and another one showing bus 2. It's always a good idea when you have one of these questions to check out what is on each of your axes. So we've got the time in hours on the x-axis, and we've got the distance in kilometers on the y-axis. That means we're going to be looking at time and distance in relation to each other. You can already anticipate that in this question. So in the first question, in question A, it says, how far did the buses travel in 8 hours? Now, if we look at the graph, you can see that we've got 8 hours right at the end here. And to determine how far they've traveled, we've got to read up onto the line and then read backward. And I can't do that very accurately on this particular image, but if you did that very carefully with a ruler on your piece of paper, you'd see that it gets to 600. So 600 kilometers is the distance that both of the buses traveled in the total time, which was 8 hours. Then question B, it says, suggest what happened to bus 2 during the 5th hour. So this is a little bit tricky. You had to be careful how you interpreted the x-axis. This here is the 1st hour, then the 2nd, then the 3rd, then the 4th, 5th, 6th, 7th, and 8th. So if we have a look at the 5th hour, that's this point to this point, and we go up and we have a look at the solid line because that's for bus 2, and we can see that there's a straight line. That indicates that time has passed but no distance was traveled. That means that the bus was stationary, it was not moving. So if you gave any answer to suggest that the bus had stopped, you would have got the marks for that question. I'm not going to write that out in full. Then question C, it says, how long did it take the buses to travel 150 kilometers? Again, we've got to look at our axes, and we look at our y-axis, where we have the distance, and we go to 150. Then we head back onto our line, and you can see, again, you do that more accurately on a piece of paper with your ruler. We look at the corresponding x value, and we can see that for 150, let's just see if we can do that a little bit more carefully. And you can see that takes us all the way to 2 hours. So it took them 2 hours to travel 150 kilometers. Right, now question D is asking us to do some comparing. So it says, which bus traveled the fastest in the last hour of the journey? That's a little bit easier to interpret. The last hour is this bit here, and we're comparing the slope of the two lines, and we want to see which one has the greater gradient or the steeper line, and that one you can see is the red line. That's bus 2. So of the two which traveled faster, bus 2 traveled faster in the last hour of the journey. Then question E is asking us, during which hour did bus 2 travel the greatest distance? That also has to do with the slope of the line, and we can have a look. Bus 2, you can see in each one of these hours the slope is the same. That means the same distance was traveled per hour. Here we know that it stopped. Here, this looks like a very steep line to me. I think the line here is a little bit less steep. This one's a little bit more tricky, and what you could do if you were answering this question in an exam is you could measure back onto your y-axis, and you could actually measure the distance. You could see how many kilometers had been traveled here, and you could see how many kilometers had been traveled there. And if you did that, you would find that it had traveled the greatest distance between hour 5 and hour 6, and as I was explaining earlier, that is the 6th hour. For question F, there is a little bit of debate, but what the question is saying is, during which hour did bus 2 travel the shortest distance? Now, strictly speaking, that's really between hour 4 and hour 5, which we know is the 5th hour, and that's because no distance was traveled at all. So we can say the 5th hour. Question G required a little bit more work. I'm going to do that down here. Samantha says that both buses are travelling at the same speed during the 7th hour. Do you agree or disagree with her statement? And you had to explain your answer. So let's have a look at the 7th hour. That's this section here. So we're comparing these two portions of the lines. And that's really again about the gradient, which one was traveling faster, because we know that a steeper gradient means a higher speed, and that's fairly easy to see. You can see that bus 2 is traveling faster than bus 1. One or two people said that the lines would be parallel if they were traveling the same speed, and that's a really good answer. That means that they would have the same gradient, and that means they would be traveling at the same speed. So what we need to say for this question is whether we agree or disagree. You could say simply no. And then you had to give the reason why you disagreed. And you could say the gradients of the lines are different. And that should be enough to get you the full marks for that question. So question 9 deals with transformation geometry, which we did as part of graph sketching. This first question is saying, state the line of reflection for the following point. So we've got the object and the image, and we've got to ask ourselves what's changed. That's fairly straightforward. You can see that the sign on the y-coordinate has changed. Now it's asking for the line of reflection, not the rule. So when we write that out, question A, this is a reflection about the x-axis, and we know that because the sign on the y-coordinate has changed. Question B now says, plot the following coordinates, P at -2, 3, Q at -5, 1, and R at 1, 2, and construct polygon PQR. Right, so we need to do that fairly carefully, and I'm going to try and do my best to get this accurate on here. So let's start with point P. We're going to know, we know is it -2 and 3, so that's going to be this point here. Then, and perhaps we should label that first actually. That's P. Then we've got -5 and 1, so that's -5 and 1 over here, and that's Q. And then the last one is 1 and 2, and that's this point over here. It's really important that you label the points, and it's also really important that you join them up, specifically because the question said construct polygon PQR. Now you need to use a ruler to do this. I don't have an insert straight line function in explain everything, so again I'm going to do my best to draw straight lines here, but these 2 points need to join up, and these points and those points, and that's our object, which doesn't look particularly fabulous, but that's about the best we can do. Please don't draw double lines in your exam. You always just draw one nice neat line. That was for 1 mark, getting that shape right. The next question was a little bit more involved, and it asked you to transform polygon PQR according to the following rule. And what this rule is explaining to us is that we've got to take our object, every point on that object, on that original polygon PQR, and for the x coordinates we've got to subtract 1, and for the y coordinates we've got to add 3. It's helpful if you do these calculations on the side of your diagram. So let's take P, and we know we've got -2 and 3, and we've got to subtract another 1 from this first coordinate. So -2 subtract 1 is going to give us -3, and the 3, we've got to add 3 to that, so that's going to give us 6, and now this is P dash. Let's take our Q next. Our original, we've got -5 and 1, and for the x coordinate we have to subtract another 1, so Q dash, we're going to have -6, and we'll have 4 because we've added 3. Lastly, let's do our R, and our object was 1 and 2, and again we've got to subtract, so subtracting 1 from the x coordinate. 1 minus 1 will give us 0, and we've got 2 add 3, that will give us 5. Now I don't actually have another color to use, but if we go back to our Cartesian plane and we've got to sketch this on as well, we're looking at this point, and this point. So P dash minus 3 and 6, which is over here. And again, labeling is really important. Then we've got Q dash, which is negative 6 and 4. That's going to be over here. And we need to label that Q dash. And then last we need our new R. So we've got R dash, which is 0, 5. And that's on the y-axis just over here. That's R dash. And then again we need to join up those points, but using a ruler. So we've got our original or our object, and we've got our image. And the second one was where there was a lot more work involved, and that's why there was a mark allocation of 3. So this last question of question 9 wasn't dealing with transformation geometry. This was actually graph sketching, and it says complete the table below and sketch the line y equals minus 2x plus 1 on the Cartesian plane below. So we've got the formula, and we've been given values of x, and those are negative 2, negative 1, 0, 1, and 2. And we have to give the output value, the corresponding output value for each one of those input values. And that requires a substitution. I'm just going to do one of them, the first one, on the side over here. So this first one, when we've got x is equal to negative 2, y is equal to negative 2 multiplied by negative 2, and that we've got from our table, plus 1. And negative 2 multiplied by negative 2 gives us positive 4, plus 1, which gives us a final answer of 5. So what we're saying here is that when x is negative 2, y will be 5. So we've got our input and our output, and we just need to complete the table. So this is going to be 5, and if we do the same substitution for each one of those values, we get y is equal to 3 when x is negative 1. When x is 0, y will be equal to 1. When x is equal to 1, y is equal to negative 1. And when x is equal to 2, then y will be equal to negative 3. And there were 2 marks allocated to getting that table correct. The other 3 marks were then for plotting each of those points correctly. So if we go onto our Cartesian plane, when x is negative 2, y is equal to 5. That's this point over here, which is not very neat. Then when x is negative 1, y is equal to 3. And that's got to be this point, the point of intersection between x is equal to negative 1 and y is equal to 3. So we need to try and get that point placed a little bit better than I have done. Then when x is equal to 0, y is equal to 1, that's this point on the on the y-axis. Then when x is equal to 1, y is equal to negative 1, and that's that point over there. And then when x is equal to 2, y is equal to negative 3, and that's this point over there, a little bit better. So there was a mark for getting those points plotted correctly, but then you also have to join each of those up, and I'm going to do my best to draw a straight line through all of those points, and don't forget that you need to put arrows on the ends of your line. So there was another mark for that, and as you can see, there are very specific points that the line cuts the x and the y axis. Then there was a mark allocated for those as well. So there was a mark for plotting, a mark for joining the points up and adding your arrows, and then just another mark to make sure that it cut the y-axis and the x-axis at the right place. And you're done.